Okay, in this second part of limit graphically, we're having one function defined in in pieces. This is why piecewise function. We are having in different intervals. The first interval will be here x less than 2, and the second one will be x bigger than equals to 2. So I've already drawn the function, but let us just go through that and I explain you what I did. We have in here a function is here for the first one here, the green function, the green color here is less than 2. It means that 2 doesn't belong to the function. So that's why we're gonna have an open point here at 2. So what do? We gave the value 2, we gave the 2 to this value here, to x here, and it gave us 2 to the power 2 plus 1. This is here 5, and of course its output will be 5, but at this position at y equals to 5, okay, y x doesn't belong to the function. We're having an open point. So now we got with plus 1 here, this is the value, the output y equals to 1 when x equals to 0, and this is what we got here. All right, and if you said coming to 1 here, for x equals to 1, okay, we're gonna have 1 to the power 2 plus 1. This is here 2, and we have here 2 right here. And we can continue by saying that, take a negative value of x, output of x minus 1. Minus 1 is going to be minus 1 to the power 2. This is 1. Plus 1 is 2. We're having 2 here. And minus 2 would be 4. Plus 1 is 5. So we're coming right here. And minus 3 would be minus 3 to the power 2. This is 9. Plus 1, it would be 10. So somewhere up there. So this is how I draw this function. And for the second one, our interval is from 2 included to plus infinity. So 2 is going to be included. So that's why we're having a closed point here. It is closed. And okay, if you consider x equals to 2 here, what is going to be his output the y-axis on the y-axis? So we're going to give it here 2 here. It doesn't minus 2 plus 3. This is 1, and this is what we got here. And if x here equals to 3, we're going to have 0, and that's what we got here on the number line on the x-axis. And now for x equals to 4, we're going to have minus 4 plus 3. This is giving us minus 1, and this is the value we get here. And minus 5 is giving us minus 2, and so on. And this is our blue function. Now we want to find the limits. Our work here, or our job here, is to find the limit right here. Okay, from the left and from the right side when x approaches 2. Okay, we will start with the first one. Graphically, we can read it. Okay, we can also put it algebraic here. Any x that is coming here approaching 2, okay, so we can see its output is 5, right? So we will say here, this is here from the negative side. It's going to give us here 5, and any x that is approaching, any x value that is approaching, from 3 approaching 2 here, I mean bigger coming to 2 and smaller going to 2, we see that its limit is going to be here 1. It's approaching 1, so we're going to say the limit here is 1. As you can see, both limits are not equal. Okay, so we're going to say the limit when x approaches 2 of the function f of x does not exist. Why? The reason is always the same. Both limits from the left and the right side are different. That's the reason why. So again, the reason why this limit doesn't exist at 2 is because the limit from the left and the limit from the right are not equal. Okay, both limits are not equal, and that's why this limit doesn't exist. So we can also write it as the limit doesn't exist. Okay, as you can see graphically, you can even take the limit, or you don't need to, but if you take it algebraically, it's going to give you the same. Just consider we're here at minus 2, and this is this function here, because this is here where x less than 2 is. We put 2 in it, we plug 2 in it here, we're going to have 2 to the power 2 is 4 plus 1 is 5, and this is the value we got here. And for x, from the positive side, we're going to have here 2 minus 2 plus 3, and this is 1, and this is what we got here. So algebraically and graphically it's possible to do, but it was important to read it on a graph, okay? Because reading it on the graph, just let you know, understand what you're doing exactly. So as you can see here, we had it from here, taking a value here, getting bigger and bigger, closer to 2. Its output is 5. That's what we got here. And we're taking another value here, we're just getting smaller, smaller, closer to 2, and its output is 1. And that's what we got here. And that's its limit. Okay. So, and because the two limits are different, the limit at this point 2 here does not exist at all. Okay. So thank you for watching again. Until next time. Bye bye.